Hi folks, thanks for checking out this video. I hope it helps as much as my normal lessons do, if not more. Um, you could fast forward or pause me. We're going to start with the warm-up like we usually do. The only difference today is since class is not live for me, I know you're watching this probably during class time, but I will be giving you points for the warm-up later today or possibly tomorrow whenever I get my computer cranked up again. We're going to be getting into the zeros of polynomials. We started this lesson earlier this week and did the first four problems. Today we're going to try to wrap up those last four problems talking about zeros of polynomials. So your warm up here has you looking at this polynomial function and trying to factor it completely. This is a multiple choice situation, so please give it your best shot and choose one of these four answers and put that in your personal channel. Don't forget to put the answer that you get in your personal channel for second period. Or if you're hearing this as fourth period student, go ahead and do that as well. Okay, I will give you points for that, like I said, when I get logged in again. But go ahead and hit pause right now if you need a minute to work this out. And I'm going to keep rolling here. Try to keep this video not too long. Okay, so I'm actually going to run through that warm up if I remember to and don't get too long-winded here today. I'll come back and show the work for that. You'll notice when I post the notes here that I'm about to create for you that this is page 1. Page 2 is the warm-up we had the other day when we did the first part of this lesson. So you're going to have to scroll down through the problems to get to where I'm starting here. This is the 5th problem, if you want to think of it that way, and page 7 of this document now. Okay. So we want to find the zeros of this polynomial, and they're just having us use an interactive graph to mark where they are. The problem here, the reason this is a tougher problem than what we did the first day on this lesson, is the polynomial is not completely factored. So you take a look at p of x as it appears, and you've got a quadratic factor, a trinomial, times another quadratic factor, but that just is a binomial. What I really hope people are picking up on are the factor patterns. Primarily, we've spent some time with expressions like this, x squared minus 4. I hope your eyeball is seeing that and going, ooh, x squared minus 4 is really x squared minus 2 squared. And when you have a difference of squares, we get a really easy to remember factor pattern. It's the perfect square chunk minus the other perfect square chunk, and the perfect square chunk plus the other perfect square chunk. So what I'm talking about is whatever you're squaring and subtracting, the core, the x and the 2 in this case, are what populate this little pattern. So hopefully you can kind of break the factorization out into these two binomials with minimal effort because we've studied that pattern before. The one that's going to take a little more effort is this trinomial here. And so we know we can break this into a binomial. X times x will give us x squared. The real challenge here is what factors of 3, so what multiplies to 3 but adds up to positive 4? Okay, the reason this isn't too bad this time is because 3 is prime. 3 only has 1 times 3, or I suppose you could go -1 times -3 as another way of getting 3. Okay, now the only one of these that adds up to 4 is that first one. If I tried to add these factors to 4, I'd get -4. So the top two add up to 4. 1 plus 3 equals 4. And let me show you why that's important. So let's put the 1 and the 3 in here, both being positive this time. Down below, we could check ourselves here with the, well, I'll stick with green, x plus 1 times x plus 3. Okay, I'm just going to check, make sure I factored that right. So think of it this way. If you go through the distributive process with this little factored setup, I should get exactly x squared plus 4x plus 3 out of this. So check your work by using the distributive property. There's x squared. Then, of course, we distribute to the 3. We get 3x. And then this is why we check for addition up to 4. I get 1x from that product, and then I get my 3 from that last distribution. So here's the 4x, and then 3, of course, we get, because we used factors of 3. So you combine all those like terms, and we totally verify that this, in fact, does distribute back to what we started with. Okay, check out our factored form. X plus 1, x plus 3, x minus 2, x plus 2. You should be able to very quickly take these individual factors and solve them for their 0. Okay? It's basically whatever makes this expression 0 is going to be the 0. So if you think about x plus 3, what makes that equal 0? You're just solving that little equation and isolating x. In other words, subtracting the 3 from both sides. There's the next 0. I'll go back to my color codes here. And so you probably do this in your head and say, okay, x would have to be 2 for this one, and x would have to be negative 2 to zero out this factor. That's what we're doing. So yeah, let me stick with my color codes here. Green was -1 and -3. Okay, so you'll click and place those dots, and then for blue, those factors were -2 and +2. Okay, now the graph is not going to put a curve on the plane there. This interactive graph is just getting you to place the dots where they go because of your work with the factors. I think it's interesting, and you got to be careful, that we did a lot of work back here to figure out what the factored form was, which involved us looking at the +1 times the +3 to get the factorization. But then when we go to the graph, we're looking at zeros, and we end up dealing with -1 and -3. So be careful what part of the process you're working in when you're placing these points on the graph. Factoring it is one set of work, and then extracting the 0 from those factors usually gives you the opposite, or the 0 of that expression. All right, pause it here to write down what you need to. I'm going to keep scrolling to the next problem. We want to find the zeros of this polynomial. Okay, so again, they give us a big polynomial that's does not appear to be factored, and we're supposed to plot all the zeros. And I'm glad they said this. It's another way of saying x-intercepts. If you're talking about, I should be specific here, real zeros, not complex. We're not dealing with complex zeros today. But real zeros will turn out to be x-intercepts on a graph. Okay, so our task is to factor, if we can, this 2x cubed plus 3x squared minus 18x minus 27. Okay, so there's a big clue on this one that I want to hand you guys, because in the future, if you run into a cubic that has 4 terms like this, what you want to do is factor by grouping. Grab the first 2 higher degree terms and also take a look separately at the group of lower degree terms. And what's great is it's both even, you got 2 terms in the first group and 2 terms in the second group. So just focusing on the 2x cubed plus the 3x squared. By the way, I called this factor by grouping. This is a tactic you can research on YouTube if you want more. I actually have quite a few videos, other videos on my YouTube channel about factor by grouping method or splitting the middle term. The thing about this one though is the middle term's already split, so we're just going to jump right in to factor by grouping, which means I'm going to look for something in common between these first two terms in the blue box. And all I could pull out there is the x squared. Okay, I should keep my p of x equals intact here. And they both have an x squared. 2 and 3 don't share any unique factors other than 1. So you're going to see inside here just a 2x plus a 3 is all that's left. Okay, so I divide as much out of both of those that I can in common, and it turns out to just be the x squared. All right, so do the same kind of process with the second grouping, then negative 18x minus 27. The biggest factor you could pull there would be a 9. But really important tip, if this term is negative, go ahead and pull the negative with it. So I'm going to actually factor a negative 9 out of both of those and check out what's left. If you divide negative 18 by negative 9, you're left with 2. And the x is still there. Yeah, we weren't able to pull the x on this one because 27 doesn't have an x. Dividing negative 27 by negative 9 will leave you with a positive 3. Okay, so essentially we divided everything here by negative 9 in this group, okay? And we put the result in this little quantity here. Now, what you're probably noticing right off the heels of that step is I have a common factor. I've got 2x plus 3 and 2x plus 3 showing up in these two different chunks. So 2x plus 3 is the common factor. I'm going to pull that out here and set it in one spot. Now, the x squared and the minus 9 are what compose the other factor. Okay, so you could kind of see that just float down there, and the structure that the original 2x plus 3 was factored off of is this x squared minus 9. Well, I'm feeling pretty accomplished with this. We've got it quite a ways, but there is a way to factor it just a skosh further. 2x plus 3, of course, doesn't break down anymore, but this fancy cat right here is another difference of squares. So think of that as x minus 3 times x plus 3. And those of you that did hard work first semester with this pattern, you know what I'm talking about. This is x squared minus 3 squared. If you rephrase it, and then of course you can use that difference of squares factor pattern. All right, seeing all that, I can solve for the zeros. So what makes 2x plus 3 equal 0? Little two-step process here. You're going to subtract the 3 from both sides and then divide off the 2. So negative 3 halves, or negative 1.5, is right here. And then in purple, we can do this in our head. What makes x minus 3 0? Well, if you plug in 3, you'll get 0 for that. And on this last factor, if you plug in negative 3, it'll 0 out. All right, so 3 and negative 3 should also be noted on the graph. So you know you're done when you have a cubic and you ended with a total of 3 dots, or 3 zeros on the x-axis. That's the most zeros a cubic can have. All right, gonna keep trucking here, but pause this if you need to. We'll be taking questions on Friday when I get back. Back in action. Okay, so we've got 2 more problems. Here's this one. Now this one's partially factored. It really does look factored already. We've got the x plus 2 here at the front. What we're gonna have to do some work on is this trinomial quadratic factor we have. So trying to factor 2x squared plus 3x minus 9. Okay, now spoiler alert, I know that 2x squared really can only break down one way. I know 2x times x will give me 2x squared. Because 2 doesn't really break down any other way than 2 times 1, you're going to want to pick this off at this level if you can. Now, -9, that means we've got a positive times a negative to end up with a negative here. So we could do a little bit of guess and check and try a bunch of different things. Is it -1 times +9? Is it -3 times +3? How do you do that, right? Plus this 2 comes into play. So what I like to do is the AC method. Of course, A is my coefficient 2 here. C is -9. So we end up with 2 times -9 being -18. So I am going to use -18 to sift out the values that I need to split this middle term. So we're going to do the AC method, and then we're going to split the middle term down here. Okay, you've seen me do this in class before, but I'm going to show my work here anyways. So we are looking for factors of 18, things that multiply to -18, but add up to this b value of 3. So what adds up to +3? So factors of -18, and I'm just going to get right to it. It's not -1 times 18, because that would just add up to 17, which we don't want. We want 3. So I'm going to be a little more clever about this. -18, so I'm going to go +6 times -3. Okay, +6 times -3, that would add up to +3, but it totally multiplies to -18. So that's good. What we're going to do is steal those two values, 6 and -3, since we verified that that adds up to the middle term, 3. And I'm going to use those, so let me jump down here, 2x squared plus 3x minus 9. We're trying to factor this. What we just discovered is I could split this middle term, 3x, okay? And that's going to be 2x squared or 2x squared plus 6x minus 3x. Okay, 6x minus 3x is 3x. You'll notice I'm just writing -9 and 2x squared. Didn't mess with those terms. We just are trading out 3x for this split value now. Okay? Now, here comes the factor by grouping. Group the first two, all right, and group the last two. So the first grouping, I can pull out a 2x from both of those, and it leaves me with x plus 3. And the second group, I could pull a -3 out, and that also leaves me with an x plus 3. So x plus 3 is my common factor to both of those chunks, and my leftovers go in the other factor, so 2x and -3. Okay. So we've successfully factored that quadratic, so I can rewrite p of x now, fully factored, as, I think I used blue, so x plus 2. Okay, and that's going to give me a 0 at -2. I could kind of just write these zeros above these factors here. Then we got an x plus 3 factor and a 2x minus 3 factor. So that'll be a 0 of x equals -3 and a 0 of x equals 3/2 if you solve that. So -3 is down here, and positive 3/2 is 1.5 right here. So there are your zeros or x-intercepts that come from the factored form that we found here. One last problem. I know this video is running long. Thanks for hanging with me. This one actually reminds me a lot of our warm-up. That's kind of why I picked the warm-up. So let's start. This is a cubic, but it does not have an even number of terms. So I'm first scanning, is there a common factor I could pull out of everything? And there is. I could pull a 5x out, and it leaves x squared minus x minus 2. Okay, so This 5x, this is a factor. I could put it in parentheses if that helps, but really our task turns into, how do I factor this trinomial? And this one's going to go faster than our last one. We don't need the big fancy AC method here. We know that x times x is x squared, and we could figure out how to build -2. So factors of -2, one's going to be plus, one's going to be minus, that add up to this -1b term. So is it 1 times -2, or is it -1 times +2? Which one is it? Well, I got a clue for you. Whenever the b term is negative, you're going to make the bigger of your two factors the -1. So we're going to go with this factorization, -2 and +1, okay? Because that'll get you the correct b value. Okay, so bring everything down. We've got 5x times these two factors, and that's going to give us our zeros. So 5x equals 0 means we have a 0 at 0 if you solve that. X minus 2 equals 0. That's going to be a 0 at 2. And x plus 1, when do you equal 0? I equal 0 at -1. So there's a 0 there, there's a 0 there, and there's a 0 there. Interactive graph question. Okay, I hope that helps, but like I said, I will be posting or doing more notes and taking questions on this Friday if you need me in class. I will see you then. Thanks a bunch, everybody.